Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Know-How is brought to you by CacheFly at CacheFly.com.
This episode of Know-How is brought to you by the Ring Video Doorbell. With Ring, you can see and talk to anyone at your door from anywhere in the world using your smartphone. It's like caller ID for your home. Get $25 off the Ring Video Doorbell when you go to ring.com/knowhow.
Coming up, we have Pulse Jets.
The youngest CEO at MakerFaire.
Your questions are answered.
And part 2 of our racing quad integration. Welcome to Know-How, the show where you get bit by a cobra and struck by lightning at the same time. I'm Father Robert Ballecer.
That was a seamless intro, Padre. One of the best we've ever had.
Oh,
where
wow.
we've been, break, upgrade.
We probably should
Explain
and do these things. Yeah,
we should have worked that out before we started.
Wow. Oh, what is this?
Well, this, I think we both can agree, one of the best movies to come out of this year, Kung Fury on YouTube. This shirt came in yesterday, and I felt it was necessary for me to wear it onto the show.
Actually, okay, as much as I'm kind of wincing at our meme generator right now, it is a really, really good flick. It was put together by a bunch of people who just sort of kickstarted a campaign.
Right.
It's everything you hated but now love about the 80s.
It's like,
the hair, the music, David Hasselhoff.
Well, they have like, graphics from today, but they make it look like there's tracking and there's the VHS kind of like filter on it and stuff.
Well, how about this? You go ahead and watch Kung Fury. It's about 30 minutes. It's on YouTube. It's for free, and then you'll be able to pick up all of our references. But you know what? Let's get past the Fury, Bryan. I want to talk about the Pulse.
Yes, so geek out about some Pulse Jets?
Pulse Jets. Now, the other week we were talking about ramjets. Remember when we were talking about hypersonic speeds? It was that type of engine that actually doesn't have any moving parts.
Right.
It requires a supersonic airflow through the system, and it uses the aerodynamic shape of the inlet and the actual structure inside the engine to compress the air just from the speed of the air coming through the engine.
Right, which you have to be going very fast to be able to do that.
Yeah, you need to be going
started.
at least like Mach 3 to make it start properly.
I think I hit that in 4th gear on my motorcycle.
Yes, well, we've all seen that. There's a YouTube video of that. But of course, the issue is you have to keep the flame lit. So it's like trying to keep the flame lit in a 5,000 mile per hour windstorm, which is tough.
It sounds a little difficult.
It's challenging. There's a tremendous amount of thrust, but people had asked me, well, is that like a pulse jet? Because a pulse jet can also have no moving parts. It sounds a lot like a scramjet, but a pulse jet, you don't need supersonic speed of the air moving through the engine, the combustion chamber. The answer is no.
No.
No, not even close.
Not even close, okay.
No. To make a scramjet, I'm going to need millions of dollars of research and a high-flying, rocket-assisted
to get
airframe
you up into the atmosphere where you can then go that fast. Because you have to have that that amount of air density has to be less, right? So that you can actually
decrease the amount of friction. But the thing about a pulse jet is I can make it in my backyard. In fact, I have made
in your backyard. It sounds dangerous, Padre.
It's dangerous, and it's also very much frowned upon by your superior.
Oh, okay. So you've learned firsthand.
It's loud. It's really loud. It's like crazy great. No, seriously. One of the reasons why we haven't built one on Know-How yet, because even though I love it, is none of you would have a place to test it unless you live on a ranch where the closest person is like 15 miles away. It's too loud. It's ridiculous. It's like you can't use it without ear protection.
Wow.
Without hurting yourself.
What are you using as propellant?
I use propane.
Propane, okay, yeah.
So let me explain how this thing works. Now, in a scramjet, you've got that air moving through the engine. It gets compressed by the shape of the combustion chamber. You squirt in fuel. Normally, the heat of all that compression ignites the fuel, starts the flame, and now you've got a continuous burn through the engine, right? Supersonic air is coming in, gets compressed, is burning, and shooting out the back even faster.
Okay.
In a pulse jet, it's just like it sounds. The thrust doesn't happen continuously like you get with a scramjet. It's happening in pulses, in detonations.
Okay.
And it's happening, can be hundreds of times a second, depending on what kind of timing you use for your pulse jet. Let me show you designs for two very common pulse jets.
Is that what those are?
That's what this is. This thing that looks like
I thought it was a horn.
a horn. It actually does look like a horn. This is what we would call a valveless pulse jet. This is the one that I built. And the reason why I built it is because it's incredibly easy to do, and it's only slightly dangerous. It will only slightly explode every once in a while. So what you have is this part that's cut off. This is just a pipe, right? So that's where you would put some sort of forced air. What I used a leaf blower, a forced air device to blow air through this combustion chamber, right?
Okay.
So I've got air coming in this way. I would have a valve where it would dump propane into that air, and then I would have a spark plug that would start the flame. Right?
Okay, on like every few seconds, or not a few seconds, a few times a second?
If you do it right, you only have to do it once. So once I get the flame in this combustion chamber, it gets shot out the back of the larger nozzle, and I get thrust. Now, what that will do is, as that gas expands and then starts to cool, it's actually going to create a partial vacuum inside this combustion chamber, which will suck in air on its own.
Right.
So I no longer need that forced air device. And there should still be flame somewhere in the system, so as you're dumping in propane, it will just light again.
And just keep going.
You'll just get pop, 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 and it will create continuous thrust.
And then to stop it from continuing,
Just
you
turn
have
off
to
the
stop
fuel.
the propane.
Shut the fuel. Now, there are a couple of really bad things about this design. The first thing is, every time you get a detonation, the detonation goes everywhere, so it will come out the
The
input
other
tube as
end.
well. It's
So
not-
up the leaf blower in this case.
Yeah, so it's not super efficient. And again, it's really loud. Also, you're containing explosions. So if you have a
Right.
bad weld, it will explode on you. It's super dangerous.
How did you put together the chamber that you have there?
I actually bought muffler parts.
Okay.
It worked.
All
It
right.
worked. Now, it's super simple design, and anyone can make one of these things. In fact, Alex, yeah, this is the principle of a valveless jet. This is what it's going to look like. You have that start air. It's what I used. It was a leaf blower. You had ignition. I used a spark plug.
Right.
And then you would have an explosion. The exhaust would come out both sides. And then after the exhaust comes out, the air would start to cool, and it would draw in air from both sides. It would mix with the fuel that you're still dumping. I dump fuel continuously into the system, and it would meet the flame that already exists in the system. It would light off again, you would get exhaust, and it would start the cycle all over. So it's super simple way to get thrust, also a super simple way to blow it up.
I was going to say, what happens if all the propane isn't burnt and just keeps...
Well,
that's
that's actually one of the tricks. You need to get a stoichiometric ratio. So it's the right amount of, if you have too much propane or too little propane, it won't ignite.
Right.
You need to get the right mixture of propane and oxygen inside the combustion chamber in order for it to work. So if you just start dumping more propane, it will kind of increase thrust until you start to see thrust decrease. It means you're dumping too much propane, you've got to back it off. And same thing on the low end. If it's not generating enough thrust, or if it's not staying lit, you could increase the amount of propane to get it to that ratio, that sweet spot.
Okay, but I'm trying to imagine what you had this attached to. Was it like a shopping cart or something that you were planning on flying around on?
Skateboard.
Skateboard. With the leaf blower attached to your back? And
Well, no, because it was just a skateboard on a rail. And so we were able to propel it down the rail. No one was standing on, because no, seriously, I wasn't worried the thing was going to explode and shrapnel would go everywhere.
Yeah, okay. I could see that.
And you remember, you only need the leaf blower at the beginning. That's just for the start air, and then you remove
and then
it.
it will continue to suck air in.
Exactly.
Okay.
It's entirely self-contained. I think we have a video here, Alex, that you can play. The amazing thing about a valveless pulse jet is, go ahead and turn the volume up on this thing, because you want to hear when it detonates, it just sounds like a bumblebee. In fact, this is the sound of the V1 rockets that Germany used during World War II.
Oh.
It's painfully loud.
Yeah, this one looks pretty professional here.
Yeah, well, those. Whoa. That's your throttle. Yeah. If he runs this long enough, you'll see that assembly will get glowing red hot. It gets incredibly hot because you don't get a cooling effect like you would in, say, a jet engine where you've got cooler air coming in. This is just hot air. It's always hot, hot, hot. In fact, if you don't have the IR cut filter on your camera, like I didn't have on mine, so it just starts everything starts to look like that. That was just a very quick startup, and that thing is already glowing red hot.
Yeah, well, there's definitely not a lot of air moving over the surface of it because it's stationary.
Yeah. And Eric Duckman has it. The stoichiometric ratio for propane is 15.5 to 1. So you want 15.5 parts of air, oxygen, to 1 part of propane.
Okay, that makes sense.
Now, there is another type of pulse jet that I wanted to play with, but it's crazy complicated, and that's the valved pulse jet. What the valve pulse jet does is it gets away from this. So I don't have exhaust and intake air off both sides of the assembly. I have air coming in this way, I inject fuel, I detonate, and thrust goes out that way. And the way it does that is there's a series of valves right here. That's why it's called a valved pulse jet. It opens when air needs to come in. It closes during the combustion, during the detonation, so that all the thrust is forced out the back. This is actually an incredibly efficient design. This works very, very well. In fact, if you see, there have been military applications of pulse jets. This is what they use. It can be efficient, it can be safe. It's still very loud, but it generates a lot of thrust for not that much fuel. Is
it difficult to make the valve system?
It's very difficult because imagine you need a system that can open and close multiple times per second for the really high ratio of pulse jets, and you also need you need material that can withstand detonation over and over again. I did try to make one valved pulse jet using a butterfly valve. I thought it was a really strong butterfly valve. It ran for about 3 seconds and then just shattered. And that was steel. It was like high strength steel.
Man. So are you going to try and attach these to one of the quadcopters or something?
I was actually thinking about that. I was like, what's the smallest pulse jet I can make? And then I did the math. And a pulse jet that would actually fit on a quadcopter would generate so little thrust.
Oh, that would be sad.
Not even worth it.
Yeah. Well, it's pretty fascinating, especially when we learned about the other rocket design that they used on the space shuttle stuff.
Oh, that engine is great. By the way, we have in our community one of the engineers who used to work on that J25 engine.
Really?
Yeah, and he was trying to tell me, he's like, well, you know, the cooling of the H2 was actually a preheat system for the gas. So yeah, awesome.
So he knew all the details.
He knew all the details. Now, folks, when we come back, it's going to be your questions, our answers. But before that, when we were at MakerFaire this year, we got a chance to speak with the youngest CEO in the Silicon Valley.
Yeah, he had a pretty cool project that he was working on, and really impressed at how well he did on camera and everything too. At that age, I was like playing with my Ninja Turtles and stuff.
I was when they told me that they wanted me to interview him for Atmel, I was like, really? Are you sure?
Yeah.
Because I'm going to ask him questions. Can he give me answers? Yeah. But he did really, really well. He runs a company called TechKnow. And Alex, let's go ahead and show them by pushing the magic button. I'm Father Robert Ballecer, the digital Jesuit with Twit TV in Petaluma, here at MakerFaire 2015. We are talking about Atmel devices, specifically the partners that have taken those chipsets and put them into their own products. I'm standing next to Quinn with TechKnow, who's going to explain what this is. Now, Quinn, of course, you are, I believe, the youngest CEO that we have currently in the Silicon Valley. Why did you partner with Atmega? Why do you have their chips inside your products?
Every chip they have is very, very powerful. Each one is really inexpensive, and they're super, super easy to use, especially with the Arduino framework. So I put them into my board, the Arduino Mini, and so I put this on Kickstarter, and they basically just took me from Makerspace to Marketplace really quick. And so I got this board on Kickstarter in about February, and I raised over $45K, and it was all thanks to the Atmel chips inside, and their social media helped me, and yeah.
Atmel chipsets have been known for fast prototyping. You can go so quickly from an idea to an actual product that you could mass manufacture. Is that what you did? I mean, explain to me some of the devices that you've created.
Well, the main project I have right here is kind of like an instant black and white photo booth. It's all on receipt paper too, so it's super inexpensive. There's 2 Atmel processors, 2 of these boards. One is in the button that acts as a keyboard for a JavaScript application to run, and then the other one is connected to the thermal printer. And it only took me a few weeks to make the prototype, and yeah, I got it done right in time for MakerFaire, so I'm really happy about that.
Quinn, if they want to find out more about what you're making, where they can get it, where do they go?
They can go to qtechknow.com, QTECHKNOW.com, and I have a link to the Kickstarter project there and some of my projects that are powered by Atmel and Arduino.
Quinn, thank you very much for talking to us, and best of luck to you. It's always nice to see makers, and now you have no excuse not to get out there and create something.
You know, when he did that line, they took me from makerspace to marketplace.
Yeah.
Inside, I was just like, oh, come on.
He's got the lingo.
Actually, that was one of the impressive things about that interview, because I've interviewed CEOs before, and there's a sort of swagger that you expect from a CEO.
Yeah.
He totally had it. So good on you, Quinn.
Yeah, I was trying to think, like, at his age, I think me and Alex were playing Doom. Yeah, we weren't making things like that.
Well, but you know, that's the thing. That's what Maker has done. This is the revolution of the tinkerer. So now I can have a product, and I could remember we had Zimbit last week.
Right.
You could actually take that, bring it over to them with your design. They could turn it into something that's a nice enclosure that actually could be mass produced. It's the evolution of what it means to be a maker. Now it's not just tinkering in my garage. It's if I'm tinkering and I find something that I think people might want to buy, I can actually sell it relatively easily.
Yeah, and the whole idea between making things modular and having things work together, and it's kind of like the new Legos, is being able to take all these different chipsets and things and make them work together.
All right, well, folks, you know, making is cool, but what's even cooler is if, like Quinn, you can take a project that you're playing with and actually turn it into a service or something that people want to buy.
Yeah.
Which is why we're so happy to have, as a supporter of Know-How, Ring. Now, you've heard me talk about them before. Ring is an electronic doorbell. It's for your home. It's that thing. Now,
Somebody's here, Padre.
Now, over the years, we've seen everything in the home advance, right? Everything from the thermostat to the fire detector to home security. One of the things that hasn't really advanced is the doorbell. The doorbell is still the doorbell that we were using 30, 40, 50 years ago.
The doorbell is something I try to ignore at my house
Exactly.
because I'd never know who's ringing it, and usually when they are, it's somebody who wants to sell me something.
Which is why you're going to want a ring. In fact, if you love it, then you probably should put a ring on it.
Oh, we talked about
we did
doing
that.
that,
We
but
did.
I didn't think you were going to use that
I
line.
actually did, yeah.
They took it from marketplace to makerspace.
Now, this is the ring kit. This is what it looks like. So, you know, Brian, go ahead and be my Vanna White here. Open this thing up for me. This
like
is a
this.
self-contained kit to install. This is what I like about it. They understand that you're going to have to put this together. So they give you the drill bit. They give you the mounting screws. They give you the level to make sure that you can put this thing straight up and down. And, of course, you get the Ring doorbell. Now, you could power this one of 2 ways, or actually 2 of 2 ways. There's a USB battery in here, a lithium polymer, that's just charged off of a USB port. That will last for a year, an entire year, before needing recharging. But the mounting plate can actually attach to your current doorbell, and the current that goes to your doorbell is enough to keep this charged up forever.
Wait, I think even give you the cable to charge it up?
They give you everything. This is a self-contained kit. The way it works is it's got a couple of detectors in here. There's motion sensors, so it knows when someone's coming into an area that you get to define. Are they coming into your front yard? Are they coming right up to the door? Are they 5 feet, 10 feet, 60 feet away? That you can set. It also has this little button. Go ahead and push that button.
Yes, please.
And when you push the button, not only will they hear that, but you'll hear a ring on the inside of the house where your old doorbell was, plus you'll be able to get notifications on your phone or your tablet. Now, here's the coolest part. This is why I actually bought a Ring. This was before they were a sponsor.
You got this for your parents,
I got
right?
it for my parents because I was a little worried about, well, we were having some issues with burglaries and break-ins at their home. So I installed one of these at our house in Las Vegas. And what it allows me to do is anytime someone comes up to the front door or it sees motion, I can connect to it And like, for example, this is one of my aunts who's at the house, and there's my little dog.
Oh yeah, you can
My
even see
little
the
puppy.
dog. And it's a really wide angle lens.
It's a super wide angle, right? So because we want to be able to see everything, right?
And
so
there it goes.
There's no place to hide from the camera on this. It's basically 180 degrees, unless you can make yourself completely flat.
I'm working on it.
Yeah, and it's not just recording, because I can record to the Ring cloud service, and it will store those recordings in case something happens. And
It
I
even
want to flip
picks up
back.
audio?
Oh yeah.
Yeah, so could you talk to it? And
Yeah,
say, hey, I'm here.
that's the thing. When somebody rings the Ring, you see how these say missed calls. It will actually flash on my phone that there's someone at the door, and I can accept or decline. So if I look at the camera, I'm like, oh, I don't want to talk to this person, I decline. Yeah. If it's someone I want to talk to, or let's say I'm away from the house and it's the UPS guy,
yeah.
I can answer and say, hey, could you put it behind the planter?
Right. Oh, that's smart.
Seriously, this is one of these devices that everyone should have at their house. If you don't have a Ring, then you should get one. Yeah.
Put a ring on it.
Yeah. There are a couple of things that I want to mention about this.
Sure.
The convenience is cool, but I spoke to the chief inventor over at Ring at Mobile Focus, and his thing was they also want to really decrease the amount of crime. And so they're trying to keep people from doing what happens a lot in my parents' neighborhood, and that is people casing the joint. If someone comes up to your window and just starts looking around and checking to see if it's someone's home, you'll get a notification that there's movement. And this is so cool. And then you can keep that cloud recording and even download it if you're suspicious because strange people are coming up to your house.
Yeah,
something happens later, you've got
that
proof.
happened to a friend of mine. People didn't break in at night. They were waiting until they were gone at work during the day and just ringing the doorbell, seeing if anyone was home and waiting a little while.
Exactly. Folks, you owe it to yourself to get a Ring. You don't even have to have elderly parents in order to get one of these. Get one for your home. Get one for your gate. Get one. I mean, I was using this as a portable camera. I want to get one of these for the no-hole so people actually have to contact us before they come downstairs.
Sorry, Alex, you can't come in today.
It's like caller ID for your home, and it's a way to update your tech. Now, right now, you can get the Ring Video Doorbell for only $174. That's $25 off the normal price because Ring loves Twit TV and the Twit Army. Protect your home and have a peace of mind with Ring. Go to ring.com/knowhow. That's ring.com/knowhow. And we thank Ring for their support of know-how. Bryan,
yes.
You know what I like to do?
What?
I like to answer questions.
Our questions, your answers.
Something like that. Now, we do get a lot of questions about Wi-Fi, and for a while there I was like, oh, no more Wi-Fi questions, but I realized everyone's using it, so we should probably answer it as much as possible.
Wi-Fi has been around for a little while, right?
Yeah, a couple
and
years.
There's a lot of issues that come with it.
And this is actually a big one. This one's from Brett B. Well, what did he need, Bryan?
He asked, Padre, dealing with Wi-Fi interference in the 2.4 gigahertz range coming from my wireless security cameras, would the Cantenna help with getting my wireless router signal through the interference so that my laptop will get a good signal? Don't have 5 gigahertz Wi-Fi adapters for all my computers, so stuck with 2.4 right now.
Okay, so good question. And actually, this is a very good one to answer.
Yeah.
We get this a lot. So you're in, say, an apartment building, and you open up your phone, and there are 40 different access points.
Right.
All those access points are broadcasting. They're all creating RF interference with one another. What we would tend to do is we would tell people, we'll go up to the 5.8 gigahertz spectrum because 2.4 only has 3 channels. It almost gets blotted out just basically every time. He actually had a very good insight, which was, could he use something like the Cantenna or even one of these panel antennas?
And focus his Wi-Fi?
And focus the Wi-Fi. And the short answer is yes. The longer answer is kind of. The really short, long answer is not really.
All right, next question.
Next question. No, so here's how it works. This will absolutely help with both transmitting and the sensitivity of the receiving. So this panel antenna, the way it's designed is rather than like this, an Omni, which is what this is what you typically get with a wireless device. It's broadcasting energy in all directions, right? Instead of doing that, this is taking all that energy and it's focusing it in a specific direction.
Right. So that helps with long distance.
It helps with long distance, and it also, this is what Brett B was picking up on, it helps with interference, because if I'm doing this, it means I'm broadcasting in one direction rather than everywhere, and I'm not causing as much interference. It also means that I have increased sensitivity from signals coming from this direction, decrease sensitivity for signals coming from any other direction, which will help with the interference.
Makes sense.
Right? Which is good because what some people are apt to do is they just turn up the transmitter on the AP, thinking, well, more power, more better.
Right.
But that just helps broadcast. It doesn't help with reception. And remember, Wi-Fi needs to be 2 waves.
I feel like you're getting to a but here with this.
Getting to a but. And the but is if you don't have an antenna on the other device,
then it's not going to work.
Well, it will help, but it's not nearly as efficient. Because remember, even if you do this and you aim it straight at your cameras, you will probably get better reception. It will help, but the problem is the camera is still broadcasting everywhere. And if it's broadcasting everywhere and it's receiving from everything, this will clear up some of the interference, but not enough to really make a huge difference. And it really depends on the environment. Now, what I have seen is there are cameras, in fact, there are some cheap cameras that have removable antennas. And if you have one with a removable antenna and
you can just attach that.
Exactly. If you have one of these on either side, one on an AP and one on the camera, and you point them at each other, it absolutely will help because now you are increasing directionality and sensitivity on both ends, and you can basically cut out the rest of the RF world.
Okay.
Make sense?
Yeah, it does make sense. So he has 5 gigahertz Wi-Fi adapters for all his computers.
No, he doesn't have. He doesn't.
Oh, he
have.
doesn't. Oh,
Right.
he doesn't have.
So
5.
he's stuck with 2.4 for now. So that's probably your best bet.
Okay.
Now, when you do go shopping for antennas, know that you can buy both 5.8 gigahertz and 2.4 gigahertz antennas. You need the 2.4 if you're using 2.4.
Yeah.
Now, the other caveat here is you're going to need devices that have the ability to attach these antennas. And you really don't want to hack them. So to make sure you've got the kind, like the SMA antenna ports, where you can unscrew the antenna and connect one of these. And these are cheap. I got this one on Amazon for like $5.
Oh, okay.
Yeah.
And then what about the omnidirectional one?
The omnidirectional was like $2 because it really doesn't help.
Oh, okay. Yeah. So why would you want it?
This was one of those buy for $2 and there's a $5 rebate. I'm like, okay. Might make for a good prop.
Well, it did.
All right, that's our Wi-Fi question. What else we got, Brian?
This one comes from Donald Weller. So I'm shopping for a transmitter for the new 250 build. I would like room to grow and like the features you discussed on Know-How, like the 50% throttle slow left turn, but I can't seem to find how to find those features.
Yes. Okay, so here's the thing. We have been using the FlySky T6,
Right.
which I recommended because A, it's cheap. I mean, it's
Right.
$35 to $50, and it's actually a really good radio setup.
Yeah, I like it.
Not
You
the
need
best.
multiple profiles
Right.
and all the little bells and whistles that you would probably
You can set
need.
throttle curve and yeah, exactly. So it's a good, for the cost, that is a fantastic radio system. But there are much better radio systems that have all the features that you're looking for.
And I see you got me one.
Yeah.
For thank you.
Your birthday. Yeah, this is my new hotness. Now, the brand is called Free Sky. I call it Father Sky for obvious reasons.
Right.
The cool thing about this is it's running
Welcome to OpenTX.
OpenTX. This is an
Hello, TX.
open source. This actually has an operating system. It's telling me that my switches are on. It's a smart controller, but sometimes it's too smart for its own good. There we go. Now, this will do absolutely everything that you want. If you can afford it, this is the radio that you'll love. First of all of the receivers are diversity, which means it's going to pick up from the strongest signal. So I can hang one of these antennas off, say, the bottom of the craft,
And
one
one on
off the top, and it will use the signal that's strongest. And
Nice.
this also does, I'm not sure if you could, yeah, you can't see that, but these modules do telemetry, which means on my screen, I will get how fast am I going? How high am I?
Yeah.
What signal strength do I have?
Battery level?
Battery level. It'll tell me,
Yeah.
is your craft starting to run out of battery?
That's
if
cool.
I crash, I can actually use the telemetry on this to DF. I can direction find to find it in the weeds. And this is a fantastic, I haven't even scratched the surface of what this thing can do.
This
and
is
I love
what
it.
like the pro FPV people use, right?
Exactly, yeah,
what
yeah.
was his name that you're showing me? The really
Sharpoo.
good-
Yeah, Sharpoo. He uses. In fact, most folks either use this or the Spectrum DX8.
Use the Father Sky.
Yeah,
Father Sky.
the Father Sky. The DX8, however, is an 8-channel. This can do 16 channels by using the S bus. So there's 8 channels here, but I can use PPM instead of PWM and rather than 8 channels, I can get 16 channels of control. I mean, it's outstanding. The other things I really like about this is, you heard at the beginning, the voice control. So it will start to warn me when when my signal's degrading.
Oh, I see.
So you know how with the FlySky, you're always like, well, should I fly it a little further? Am I gonna go out of that?
Yeah, you're never quite sure you're gonna get out of range until it starts to fly away from you.
This will actually give you an audible beep saying, hey, I'm starting to lose signal here, so you might want to bring it back.
Nice.
And the receivers on this will do, right here, this little button allows you to set the safe mode, the fail-safe. The menu is actually difficult to navigate here. Let me go to the page, but it does allow me, let's see if I can find it. It allows me to set what my fail-safe will do. Internal RF. Yeah, there it is. So if I want to tell it what it does when I'm losing signal, it's all in here. I have the ability to say, okay, go to 0 throttle or stay where you are.
Yeah.
Or what I've actually told it to do is I told it to go back to like half throttle, which I know is hover, and put it into a left turn.
And then it'll circle back to you.
It'll just keep circling, right?
Yeah.
So this is a great radio. The problem is, it's about $250.
Ooh.
Yeah, so it's a significant jump from the FlySky.
And all that stuff sounds awesome, but do you think it would be kind of overkill for someone just starting to get into it?
That's why I don't recommend this for someone. If you're just starting, all of these options, it will freak you out. The FlySky is so much easier to use, and it is a natural step. Once you figure out the FlySky, the settings on this actually make a lot more sense. If I had gotten this as my first,
you would have been overwhelmed.
I would have no idea what I'm doing.
Yeah, because I'm looking at that menu system, and I'm like, I wouldn't know what to do with half of that.
Yeah, so save up for this. I mean, it is worth it. This is a really good radio system. The receivers are also going to be more expensive. This is the one I prefer, the XR8. This has the smarter bus on it. These are going to go for about $30 each versus they were like $7 to $9 each for the FlySky system.
Yeah.
But they are so much more capable. Oh, one other thing I really like about this, in the back, there's this area for modules. I can plug in other modules and control other radio systems. I can change from a 2.4 gigahertz control channel to like a 900 megahertz channel if I'm worried about range and interference. There's even a module for this that will allow me to fly the SEMA quadcopters off of this.
That's cool.
So yeah, it's
yeah,
nice.
man, that has all the tricks to it.
It really does. Well, because it's programmable. I can program the open source software myself. I wouldn't do it because I don't want to crash. Because every time I've done it, I've crashed. But yeah.
But so if you get this, do you ever have to buy another controller ever again?
When you break this eventually.
Yeah, eventually. Yeah. I'm so angry.
I mean, they're always coming out with new things, but that's really what that module is for.
Yeah,
so
that's
I can
cool.
expand it. This is a fantastic, fantastic radio. One of the other things I like about this versus the FlySky lets you do multiple profiles. But all receivers are active on all profiles. So if I bind it with 5 receivers, and I'm in the profile for 1, it will still fly all 5 receivers.
Right.
Right. This, when I switch profile, it will only work with the receiver that profile belongs to.
That's smart.
Yeah. So there you go. The Father Sky. This is the Tyrannus 9XD. Take a look.
Cool. So should we answer one more question?
Let's do one more.
All right. This comes from James Hughes, and he has a question about the Vinci from XYZ. He's been having issues printing larger items. It seems that the front right corner lifts and distorts the print. This happens consistently. I have tried moving the print as far back as possible, different filament, changing the speed to slow, all to no avail. It works great on small items, but I am trying to print a case for a custom build. I'm wondering if the changing the print temperature to 230 C will help. Could it be that the bed needs to be adjusted? The print starts out fine, and then after about 30 minutes, the corner starts lifting and just gets worse as the print continues.
James, thank you for this question. This is actually a very common occurrence, so I'm very glad that you brought it up. First, changing the print temp will not help. In fact, that might exacerbate the problem. Also, it could be bed misalignment, but probably not. This is actually a very common occurrence with people who are running 3D prints. You see, the problem that we have is you have to heat up the material, be it PLA or ABS, in order to get it to flow through the extruder. Now, as we all know from physics, when you heat something up, it tends to expand, right? I mean, material expands when you heat it up. The problem is, after it's laid it down, it's going to start to contract.
Right, start cooling.
Yeah, and if it happens too quickly or if it happens too irregularly, it will actually pull up a corner. So it's very you can see that.
Yeah,
I
I
don't
can
know.
see it on yours too.
Exactly. So this was a large enclosure box that I printed. It will still work, but like if I were to lay this flat, you can't really see it. If I were to lay it flat, you would see that this corner and this corner have slightly pulled back.
Right.
That's exactly what you're doing. Now, smaller prints, you won't normally get that because it's such a small amount of material that even when it shrinks, there's not enough force to pull back the material from the corners.
Right.
But larger prints, you have so much material there that the shrinkage really does make a difference. Now, there is a couple of different ways to beat this. With ABS, because there is such a strong pull from the cooling material,
right.
they use what's called a heated bed. It's basically a blanket warmer that keeps the bed hot so that you don't have that differing temperature that will cause curling.
Right.
We don't have that on PLA printers. In fact, that's one of the reasons why we like the PLA printers, because you don't have to do that. Because ABS also releases a horrible toxic smell.
Okay.
But
Yeah,
with PLA, you still do get that effect. The way that I have found to minimize that, this is going to sound strange, but it actually works. Make sure the room isn't super cold.
The room that you're printing in,
That you're printing in. Keep the door closed. And I've actually put a blanket over the top of it. You still want the outlet so it can cool off, but you don't want a variance. You don't want the print head to be at 200 degrees and the bed to be at 100 degrees, and then like right outside the bed it's 40 degrees. That's not good. That will cause a lot of shrinkage. The other thing that you can do is use watered down Elmer's glue. That's the glue stick that you get in grammar school. Let it slightly dry. You want it to adhere the print. In fact, the stickier the better. What I've normally done for this larger print, in fact, the one I made successfully without the curling, I used a very nice layer of Elmer's glue. It stuck so much I couldn't remove it. I had to soak the glass plate overnight to get the thing to come off the print.
Wow.
But that's so much better than having curl on you.
Yeah, well, and this is probably the exact size of the bed, right?
Yeah,
is this
that's as big as it can get.
As big as it gets. So yeah, if you can minimize the size, it probably would help. But so you're saying keep things warm to prevent shrinkage? Good.
How long
Good to
have
know.
you been waiting to...
I don't know what you're talking about.
You're stacking that up. Someone was saying use acetone. So JJ to the 4884, use acetone. Yeah, the cleaner that you can make the glass, the better the adherence. So what you're having is really, it's an adherence problem. You need the print to stick to the glass until it's done. So if you're not cleaning in between prints, that would be a really good thing to do. In fact, like, don't just wipe it down. Actually take the glass plate out of the Da Vinci Junior, soak it, clean it in acetone, get it squeaky clean, then put a film, a nice thin film of Elmer's glue, water it down a little bit so it looks really uniform. Let it dry, put it back in, give it a shot.
Cool. When are you going to bring the Da Vinci back to the studio so that I can play with it?
I don't know what you're talking about.
Did you use up all the filament and send it back?
I did.
Yeah.
But I bought another one, so.
I thought you said we needed a 3D printer for the no-hole.
We do. I'll bring it in, fine. I'm trying to harsh my 3D mellow. Folks, now is the time where if you don't want to see the quadcopter project, you can bow out. That's why we kept it to the end of the show. I know some people are a little tired of them, but if you are building the KH, the Know-How 250 Racer, here's part 2 of our integration. The last time we saw Project Know-How 250, we mounted our motors, soldered our ESCs and power distribution harness, and assembled the base of our frame. Now we need to build the flight controller, mount it to our frame, calibrate the ESCs, and integrate the control system. The first thing we need to do is to make sure our computer is set up to connect to the flip. Download the WinGUI interface from Ready to Fly Quads, then connect your flip to a USB port and run the software. Once up and running, connect the software to the flip and click on the Flight Deck tab. You should see a confirmation of the telemetry link and the artificial horizon should be working. Now that we know that the board is working and we can interface with our computer, it's time to risk damaging it. If you ordered the flip flight controller pre-soldered, then you can skip this part. But if you got the bare board and pins because you like a challenge, let's get soldering. As before, you'll need a soldering kit and some 0.75mm solder or finer.
You'll also need a sharp blade to break off the pins from their strips, as well as a hard surface against which to place the pin headers while soldering. Start by examining your new flip flight controller. Rotate the board so that the micro USB port is pointed forward. This is the front of the controller. The flip must be mounted with that port facing the front of your quadcopter for proper orientation and operation. With the USB port still pointed forward, look for the 6 rows of triple through holes. That's where we're going to connect the flip to our receiver. The 4 rows of triple through holes at the bottom of the controller, just left to the marked offset of through holes, that's where we're going to connect our ESCs. Flipping the board over shows you pin assignments, silk-screened into the bottom of the flip. You may want to snap a picture for reference. You may be wondering what the 2 rows of single through holes are for. Well, that's for the addition of devices like barometers, compasses, and Bluetooth radios for wireless setup. But we don't need those pins for this build. Using your knife of choice and a hard surface, break off a set of 6 and a set of 4 rows of pins. Ready-to-fly quads usually packs in more pins than needed, so don't worry if you break a row or 2. Also, you're dealing with a sharp edge, so eye protection and safety first. Now we're going to solder those pins into the through holes we previously identified. Typically, I like to use the hard surface to push all the pins to a uniform length within the plastic retainer. Then rest it on a hard surface and position the board on top of it. Start with the array of 4 triple pins. Make sure not to put any pressure on the board, as that will misalign the pins. When soldering pins in through-hole mounts, you always want to apply heat to the pin, not the board. Pushing too much heat into the board will damage or destroy your flight controller. A good method is to touch a tin soldering tip to a pin, let it heat for a moment, then touch the solder to the junction of the pin and the board. If the pin is hot enough, solder will quickly flow down the pin into the through hole, creating a bond. Don't put too much. You don't want a blob, just a solid connection. Tack a pin on either side of the pin assembly, then inspect the board to make sure your pins are still level. If they are, return the board to your service and repeat the process for all the pins in the array. When you're finished with the first array of pins, repeat the process for the other set. Once you're done with both sets, inspect your work. First, look for any bridging between pins and through holes. There can't be any stray solder between the pins that could cause a short. I like to use a wire brush or stiff toothbrush to clean between the junctions and snips to shorten excess pin lengths on the bottom. Also look for any cold joints, gaps in solder, or pins that aren't quite bonded. When you're satisfied with your work, once again, connect your flight controller to your computer to make sure it's still working. If it links, go ahead and mount the flip on top of the spacers that you previously installed above the power distribution board. If you're worried about your pins being a bit sharp, use a small square of the Velcro strip or a square of double-sided tape to insulate the bottom from the ESC power cables before securing it with 4 M3 6mm screws, the ones that came with your motors. Now is a good time to calibrate our ESCs. This will require us to run power through our power harness for the first time. If you have any bridge connection, shorted wires, bad insulation, or stray solder, you're about to find it. So take a little time to re-examine your handiwork and put on a set of safety glasses just in case. Unlike the KK controller we've been using in our previous builds, the flip doesn't have a throttle bypass, so we're going to use our radio. Connect the control cable from one of your ESCs to the throttle channel on your receiver. If you're using the FlySky system, it's channel 3. Turn on your transmitter and throttle all the way up. Now it's time for a moment of truthiness. Connect the XT60 connector to a battery and hopefully there's no blue smoke. Instead, you should hear the ESC beep telling you that it has calibrated full throttle. Move your throttle to the 0% power setting and the ESC will beep again, telling you that it has calibrated 0% throttle. Disconnect the battery and repeat the process for the remaining 3 ESCs. With the ESCs calibrated and the battery disconnected, we can now plug them to the flight controller. We'll be connecting the ESC control leads to the 4 rows of pins at the bottom of the flip. On the flip, ground is always to the outside of the board, signal to the inside. Your power leads will differ in wire color, but typically ground will be black or brown, and signal will be white or a light-colored wire. Remember in the first Project Know-How 250 segment when I told you to make a note of the number of the arms? Well, now we're going to use that numbering. Looking to the pins at the bottom of the flip from left to right, connect the first row of pins to the ESC on arm 1, the next to the ESC on arm 3, the next to the ESC on arm 2, and the rightmost pins to the ESC on arm 4. Once again, make sure that you've got the ground pins to the outside of the board. Next up is connecting the pins on the right side of your flight controller to your receiver. The exact procedure will vary from receiver to receiver based on the configuration of your chosen radio, but the top row of pins on the flip should be connected to your throttle, the second row to the aileron, third to the elevator, fourth to the yaw control, and the last 2 rows of pins to your auxiliary channels. Once again, ground on the outside, signal on the inside. Let's have our second moment of truthiness. Once again, connect the battery to the craft, again prepared for blue smoke if the FC wasn't soldered properly, and look for the red and blue lights on the flip. If you see them without smoke, congrats! You've probably successfully integrated your control system. In the next episode of Project Know-How 250, we're going to guide you through the configuration of the flight controller, check rotation of your motors, clean up your wiring layout, button up the frame, and have our craft ready to fly.
I want to repeat this because I'm sure we're going to get people posting in the Google Plus group that their quad just starts to flip over immediately.
Yeah, you want to do 1, 3, 2, 4.
1, 3, 2, 4. Which is why I brought attention to it in both segments we've had so far. In the KK, we plug it in 1, 2, 3, 4. On this, it plugs in 1, 3, 2, 4. Just make sure you do it that way. Well, how about this? The first time it just flips over for no reason, check your wiring.
Okay.
Yeah. The other thing is, you may have noticed I actually installed a Velcro band at the bottom.
That's for the battery, right?
It's for the battery. The reason why I didn't put that in the first episode is not everyone wants to put the battery down there. Some people like to put the battery on the top. Some people don't actually like the strap because it breaks the lines of their quad. So I'll leave that up to you. You know, it's an aesthetic choice that you can make. But this thing is pretty much ready to go. Next week, all we have to do is I'm going to show you how to do the configuration of the board because we still have to calibrate the magnetometer. We need to make sure the accelerometer is working properly. We do want to change a couple of the default settings. One of the things I like about this is the arming for this will actually be a switch. There'll be a physical switch that you have to click for it to arm. So it's not anymore. It's not that stick movement down into the right or down into the left.
Right.
You'll be able to change all that in the firmware. And the other cool thing is, at some point, we're going to break this out to the Bluetooth module so you can get that telemetry screen on your computer as you've got this in the air.
Yeah, that's what I really like. Yeah. And couldn't you do GPS with it too?
Yeah, I mean, this does have a full bus.
That's awesome.
This will communicate with the magnetometer. It will communicate with, there is a GPS device you could use on this. I prefer to use GPS on higher level flight controllers, but you can do it on this if you want. It's a wonderfully reliable flight controller. But what I really like about this, and the reason why we're using it, is it's really good for flipping, hence the name. It does this hybrid self-leveling where if your stick is towards the middle, it will fly like it's full auto.
Yeah.
But when you go to the side, it will turn everything off and it will allow you to flip and then immediately recover back to full auto.
Yeah, I still haven't tried that. Because on my controller, I have to go full manual, and I'm afraid
That's that feeling, stop. And remember, we're also going to be doing some crazy FPV stuff with this. That's what this frame is for. We're going to be installing a GoPro camera, an FPV receiver. There's actually a small gimbal that I can install on this, and it will work just fine with the amount of thrust that we're going to be developing. So, yeah, this project's got legs.
Yeah, those motors look mean.
They are.
Yeah,
they're so nice.
Powerful.
In fact, it's too powerful. One of the things that you'll see when we get this up, because we're going to put 5x3x3 propellers on this. If you punch out, if you go full throttle, it actually cavitates the air, and you get this. It sounds like it's screaming at you.
Jeez.
So
this one doesn't need a pulse jet on it.
No. It is a pulse jet.
It is a pulse jet.
Yeah.
She's scary.
Now, we know that this was a lot of information, so don't forget that you can always go to our show page. We'll give you notes. In fact, I'll be having step-by-step instructions that we can put up there. So you don't have to watch the video over and over and over. You can just follow what you see on the screen.
Yep.
Brian, where do they find those notes?
The same place they can find all our previous episodes at twit.tv/KH, the newly revamped website. We've got all our show notes there, links to any products that we might have used in the episode, and our crazy screenshots that we use.
We're doing more and more of those. You know, we probably should figure out what we're doing before we actually do it. Because today was kind of an aborted attempt.
It's okay. We can re-record the beginning.
Right.
Have you even recorded any of this so far, Alex? Could we just start over again?
Well,
The red button wasn't on.
Dang, that's okay. That's okay. Also, don't forget that you can find us on Google+. We've got a community that's 8,000, almost 9,000 strong. Join us or tell a friend to join us. Just go to Google+, look for the Know How community, post pictures of your projects. That's where we like to get a lot of our material. That's where we get your questions. If you want something for us to answer, that's where you would post it. And if you've got a project that crashes and burns, please post that too, because we'd love to show that
I've seen people say that they want to see more of my quadcopter videos for some reason. Maybe it was because I crashed within the first 15 minutes of using the 450.
I never
Who
crash.
knows?
I never crash.
You never crash.
Are you kidding me?
Oh,
I've
great.
broken so many props. I made a chair. It's the Game of Drones chair. It's made from my broken props.
Yeah.
It's quite nice,
it's like a little quad chair. Yeah, well, somebody was saying that you use the gloves to build your quads so that there's no fingerprint evidence on them.
Well, I mean, if you crash this in a populated area, you don't want the police coming back to find you, right? So, I mean, just make sure there's no fingerprints. Yeah. Also, don't forget that you can find us on Twitter. You'll find me at twitter.com/PadreSJ. If you follow me there, you'll find out what we're going to be doing on every episode of Know How. You'll also find out what I'm going to be doing on the other shows I do here on the Twit TV network, as well as like when I go flying and I crash something into the Pacific, I put the pictures there.
If there's any footage to be found. And for other behind-the-scenes stuff, you can also find me on Twitter at @cranky_hippo. And we wouldn't be able to do this show without our director. Hal.
Yeah. What's
Hal
his name
something?
again?
I think
Grumble.
Yeah, I don't know.
Grumpy Pants.
Something like that.
Grumpy Cat.
Excuse me, Brian, that's Gumple.
Oh, right. I think I would have got that by now.
Also, special thanks to our in-studio audience today. They come to us all the way from, I forget again, it's the Tuolumne County. That's John and Nikki. They have confessed to watching 4 to 5 Twitch shows, which that's amazing.
Total, right?
Yeah.
No.
That's every week. We thank you. And you know what, folks? You can always come in to watch an episode of Know How. It's fun. Just write to us or email us and get tickets to
Bring your
here
quad with you.
in Petaluma. Yeah. Until next time, I'm Father Robert Ballecer.
And I'm Bryan Burnett.
And now that you know how,
Go do it.
Billboards real quick.
You're like a father to me.
Oh, wait.
I think I just threw up in my head. Oh, look! Oh my God! I didn't realize I was in this video. No. No. You know, here's the scary part. Back in the 80s when they shot this video, most of America wasn't obese.